Good afternoon. I just want to emphasize something and on sample problem C. So here we have they're asking us to write the formula for tin 4 sulfate. Now I want you to note that the Roman number here 4, as you can see, indicates the oxidation number of tin. Okay, so the 4 over here, this is 4. So whenever you see that, you should immediately write the oxidation number. So that's +4, okay? And then you have sulfate, which you already know is SO4 minus 2, okay? Based on that, we're going to start our calculations. Okay, so when I look at this, I have a +4 and I have a -2. You could solve this in two ways. So if we're going to use the crisscross method, of course they're different. Remember, I always taught you that we use the crisscross method when they're different. Okay, but I want you to notice something. Now, when you're applying crisscross, if the numbers are multiples of each other, so over here we have the 4. 4 is a multiple of 2, right? In that case, we only multiply the smaller number by the number that will add up and give us the same absolute value. Okay, so we want these to be equal. So in that case, I'm going to do the crisscross method here, and then what I get is that I get the subscripts 2 and 4, right? Because doing the crisscross, the result of that is that the SN is going to be multiplied by 2, and the SO4, the sulfate, is going to be multiplied by 4. So over here I have 2 and 4, and these are multiples of each other, right? The 4 is a multiple of 2. In that case, I have to follow the rule that says the smallest whole number ratio. Okay, so what does that mean? I have to find the smallest ratio of these. So that means that these two numbers can be divided by the largest common factor. Okay, and it says here largest common factor. They're giving you the method. So basically that means that we're going to divide 2 by 2 and the 4 divided by 2. Dividing that gives you 1 over here, and dividing 4 by 2 gives you 2. So this is the final result. So this is the first method. The second method to do this is to apply the linear equation method. Remember the linear equation method? So the oxidation numbers have to add up to 0. So here I have, in other words, I have to have the absolute value, the same absolute value on both the cation and the anion, but I have to have them in different signs, positive and negative, so that I can cancel them. So the only way to get this number to be -4 so that it can cancel with the +4 is to multiply it by 2. Okay, so doing that, so the number that you multiply with is just added over here. And there you go. You have the same result. Okay, same result. I just want you to pay attention here that this is iron 2, so the Roman number corresponds to the oxidation number, +3, and that's +1. Okay, and then, so remember, these you have to memorize. Okay, figure 1-3. And figure 1-1 also. But this is not included. Okay, guys, this is not included in your test, or you don't actually need it for your, it's not a requirement for College Board for your test. Page 216 and 2